Hey guys, Mr. Middleton here. Today we're going to continue with our triangle proofs chapter by talking about proving congruency by angle, side, angle, and angle, angle, side. Okay, at the end of this video you should be able to identify angle, side, angle, and angle, angle, side congruence between two triangles, and you should be able to prove two triangles are congruent using any of the shortcuts learned so far. Side, 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 angle, side, angle, and angle, angle, side. Yesterday we learned two shortcuts proving triangles are congruent. Those were side, 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 and side, angle, side. Remember that A was the included angle. Included angle. Okay. Today, we'll learn about two more shortcuts. First one is the side, angle, side, angle, side, angle postulate. Okay. And what that says is if two angles and the included side of a triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Remember yesterday when we talked about included angle, that meant that the angle needed to be in between the two sides that we were marking. When we talk about included side, the side needs to be in between the two angles that we're marking. And so for this first example, just kind of making sure we understand that, it says, name the two triangles that are congruent by angle, side, angle. Okay, and so important part, we're making sure that this side is included. Okay, notice that in this triangle, the side is not included. The side that's marked is NF, but NF is not between the angles marked angle N and angle I. So that's out of the picture. We're going to name these two triangles congruent. Remember, for our congruent statement, we can start with whatever order that we want to. So I'm going to say triangle CAT, because that spells cat. Okay, and now I did that because it spelled cat, so I need to make sure that I pay attention to the next triangle. C has one arc. What goes with that? G. A has two arcs, and that's next. So what has two arcs? D. T has no arcs. What has no arcs? O. Okay, really tricky, especially when you use words that I say triangle cat and somebody says, oh, triangle dog, because it's a possibility. But remember that it does matter that your angles match up with their corresponding angles. C and G have the same markings. They go in the same spot. All right? Okay, angle, angle, side theorem says if two angles and a non-included side, okay, this is non-included. Okay, so if you know what an included side is, that means you know what a non-included side is. It's a side that's not in between the two angles. So if two angles and a non-included side are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. So notice that two angles have one included side and have two non-included sides. Okay, so let's delve into that a little bit down here. Example says, answer the questions using the diagram below, this diagram. How do we know that angle PQT is congruent to angle SQR? Okay, I see an X. That leads me to think, okay, vertical angles. I know these two are congruent because of vertical angles theorem. Vertical angles theorem. Remember that theorem says that all vertical angles are congruent. Boom. Boom, I'm going to mark them. Makes me know that I've done it, I've written it down, and I can use it visually. Okay, which sides need to be congruent to have an angle side angle congruence? Okay, remember this is side in between the angles. That means it needs to be included. So what are the included sides? Well, PQ is included because it's in between the two arcs. PQ would need to be congruent to SQ. Okay, again, it's between the two arcs of the other triangle. Which sides need to be congruent to have angle side congruence? So notice here, the sides outside is not included. So we're going to have non-included sides. So I would say, okay, QR. Maybe I'll start with this one, QR and QT. or RS and PT? Okay, so we would need one of those. Not both of those, but one of them. Okay. Now, we talked about the 4 shortcuts that use S's and A's. Please notice that there is no ASS shortcut, or, most people will say it can't be an ASS shortcut. There's no SSA shortcut. Don't write that down. It doesn't work out for us. Okay. All right. So we have some time. Let's go through a few of these proofs, kind of increasing the difficulty as we go. Getting some practice. What I would do if I were you is, if you watch the first one, you're like, I think I can do this, do the next 2, try them out, and then come back and watch this. Or if you don't want to watch the first one because you saw one yesterday and you're like, yeah, I got it, then just try them out and then come back and see what you did. All right, so here we go. We're going to prove that triangle PTQ is congruent to triangle SRQ. Okay, and in proving this, we should probably walk through our proof a little bit to make sure that we know kind of where we're heading to. So they told us that Q is the midpoint of PS. Q is the midpoint of PS. So how I'm going to use that is I'm going to say, since Q is the midpoint, I know that these two will be congruent to each other. I have that. See an X, I see some vertical angles. Okay, I can prove this by angle, side angle. All right, so I know that I'm probably leading up to proving this by angle, side angle. Let's walk through it formally now. Okay, and that's probably what I would do if I were you guys before I started. I hate to get 4 or 5 steps into a proof and say, oh, that's not what I want to do. Okay, so to start off, I'll say, okay, Q is the midpoint of PS. Okay, and that's given to us. Now remember, I'm not going to be done with this statement until I get to mark something on my diagram. Okay, if Q is the midpoint of PS, what does that help me to say? Well, now I can say PQ is congruent to SQ. And why can I say that? Well, that's what a midpoint does. So that's the definition of midpoint. Anytime I can say that's what that does, it's definition of whatever I'm talking about. In this case, it's midpoint. Okay, they already told me, or they gave me, that angle P is congruent to angle S. That's given. Remember, I can say just P and S because there's no, you can't confuse it. Those are the only angles we have drawn there. And then next we talked about vertical angles, right? So we say angle PQT is congruent to angle SQR because of the vertical angles theorem. Vertical angles theorem. Okay. And so I'm going to mark that. All right. So I feel pretty good about this. I have my markings down. And just like we said before, we can prove that these two triangles, triangle PQT, or actually, I should say what they told me to prove, PTQ is congruent to triangle SRQ, and we can say that because of angle, side, angle. Okay. All right. Next, let's get this next one. Okay. These difficulty level numbers are just arbitrary things of what I think the difficulty is. So you don't have to go too far into them. But I tried to increase the difficulty as we went through. Okay, so again, I'm going to go through this and see, okay, what am I going to prove here? So they didn't give me anything in the diagram. Rn bisects M and P. Rn bisects M and P. That means it cuts it in half. Okay, so I'm going to have that. Mn is congruent, or angle M is congruent to angle P, so I'm going to have that. Okay, I see that this is in both of them, so I'm going to have that. Okay, angle, angle, side. All right, so I'm probably going to prove this by angle, angle, side. So now I'm going to go through and make sure I can do that. So I'll start with the given. They told me that Rn bisects angle MNP. That was given. Number 2, Because of this, remember I didn't get to mark anything with this statement, so I'm not done. Because RN bisects angle MNP, I can say, okay, MNR, angle MNR, is congruent to angle PNR. Okay, again, because that's what a bisector does. Definition of angle bisector. Okay, and so now I get to mark that. These two angles are congruent to each other. Okay, they told me that angle M is congruent to angle P. That was just given. Okay, good, so I'm going to mark that. Sweet. And now I said, okay, this NR is in both triangles, so I know that NR has to be congruent to itself. So that's the reflexive property. Reflexive property of equality, but I'm just going to say reflexive property. And so I have my mark. And now I can say, okay, I got two angles and a not included side, so I'm going to say that triangle MNR is congruent to triangle PNR by angle, angle, side. Okay? And last one, difficulty level high here, mostly because of excuse me. Mostly because of parallel lines. But remember, whenever you see parallel lines in your head, you should think corresponding angles, alternate interior angles, same side interior angles. Okay, so I'm going to walk through how we're going to use this proof, and then we're going to write it down. So I have an angle already. I see a shared side. It'd be really nice if I had another angle, because then I have angle, angle, side, or angle, side, angle. Okay, I have parallel lines. Okay, I'm looking for either corresponding angles, same side interior angles, alternate interior angles. Okay, so I see these alternate interior angles here. Okay, so then I'd have angle, angle, side. All right, so I'm probably going to prove these two congruent by angle, angle, side. Got that plan, now I start writing down my proof. Okay, so number one, I'm going to start with what they gave me. Angle F is congruent to angle H. I know that because it was given to me. Numero dos. Again, my second thing I found that JG was congruent to JG. Okay, and that was just a reflexive property. It was a shared side, it was part of both triangles, reflexive. Okay. Alright, now I use the fact that these lines are parallel, so I need to say that I use the fact that these lines are parallel. So I'm going to say, okay, FG is parallel to JH. I know that because it was given to me. I'm not done with that though, remember, because I want to find a marking. I want to be able to mark on my diagram something. Okay, that something congruent. Like I can mark they're parallel, but that doesn't help me prove two things are congruent by itself. So now that I say, okay, since those two are parallel, I can tell you that angle FGJ, okay, is congruent to angle HJG. Okay, and that's because of the alternate interior angles theorem. Interior angles theorem. Okay, and now I get that marking. Mark two things congruent, so I feel pretty confident that I at least use that information. Alright, and so now angle, angle, side, angle, angle, side. I can prove that these two triangles are congruent. Triangle FGJ is congruent to triangle HJG by angle, angle, side. Okay, so another proof in the books. Hopefully you're getting accustomed to it a little bit. Make sure that you're focusing on why we're writing in the order that we are. And just a quick reminder that your proofs are not just random facts put together. Notice how we took our time. We kind of made the story up before we wrote it. It's like writing an essay. You don't just write your facts down. You make sure that your facts are in a way that they build off each other and you don't move on until you make a point. Okay? Alright, and definitely make sure that we're hitting the target. They want us to prove these things. That's what our focus should be on the way. Alright, so we're down. We've got 4 shortcuts done. Talked about congruency. We'll work on some more next time. See ya.